Let's talk about an advanced technique for how to find a zero or the factors of a polynomial. I'm talking about something called the factor theorem. Now, the factor theorem says that if we have a polynomial of the degree n and we have a real number k, such that we can find a polynomial of 1 degree smaller, n minus 1, then we can rewrite it as f of x equals that k value times some other polynomial plus f of k. Now, I know it's a little strange the way I'm talking about it, but what it works out to is that if x equals k is a zero of the polynomial, then f of k equals 0. So, if k is a zero of the polynomial, we can go ahead and do this factoring here. So if we know 1 0 already, we can simplify our polynomial and find an easier way to get the factors for the rest of the polynomial. So what that works out to is if x equals k is a 0, then for f of x, x minus k is a factor. And that just goes back and forth and something that you've already noticed. If I have something like f of x equals x squared minus 3x plus 4, let me factor that guy. This guy factors to x minus 4 times x plus 1. Those are the factors. If I multiply these two, I'll get x squared minus 3x plus 4. And if I want to find the zeros, I take the factors and set them equal to 0. And I end up with x equals 4 and x equals a negative 1. So once again, if x equals, such as x equals 4, is a 0 of the polynomial, then x minus that 0, x minus 4, is a factor. So it's just going back and forth between factors and zeros. So this theorem is a little strange, as I said, or might be a little strange if it's the first time you've seen it. But what that theorem is used for, or what the theorem is used for, is to find a simpler formulation for our polynomial. So we can work through the mathematics and get the zeros of the polynomial that we're looking at. Now, we're going to use synthetic division here to illustrate this particular theorem. If you've never worked with synthetic division before, here's a quick recap of it. The technique of synthetic division is we take a polynomial, in this case it's a cubic, and we divide it by a known factor. So once again, if we know a 0 of the polynomial, then we can divide the polynomial by that factor and get a simpler polynomial to work with to find the rest of the zeros. So this is how it works. Here's our factor, x minus k. So we take k, and we take the a value in front of the highest degree, and we just drop it down. And then we say k times a, right here, and add this k times a, add it to b, and we get a new thing. And then we take that new thing and we move it over here, add it to c, and then we get a new thing. And then over here, add it to d, and then we get a new thing. And that represents f of k. And if k is a factor, f of k is equal to 0. So we can use it then with this new polynomial that we created and keep factoring. Or we can also use it to test and see if a certain number is in fact a 0 of a polynomial. Let's take a look at example 3 and see how we can do that. So, we have a factor x minus 3. The way synthetic division works is what we're saying is that x minus 3 is what we're dividing by. And if we do synthetic division using x minus 3, then the result we get from the synthetic division will be the value outputted by the function when you plug 3 in. So we'll find the value of f of 3. And if the value of f of 3 equals 0, then that means 3 is a 0 of the function. If it doesn't equal 0, then hey, we found a value that when we plugged in, this is where it is on the graph. So let's run through this example real fast. Let's see here. We're going to synthetic division. Let me go back up here so you can see the diagram. We're going to take 3, because that's what we're evaluating. X minus 3 is its factor. 3 is the value we're using. And we're going to write it here. And then we're going to create this chart. And then we're going to take the a values, or the coefficient values, I should say, in descending order. So this coefficient goes with x to the 4th, x to the 3rd goes with 5, x squared is with the 4, x is with the 12, and then 21 is the constant. So when I say in descending order, I mean the coefficients of the degrees as the degrees descend in their powers. So that means that we have negative 3, 5, 4, 12, and 21. So we're going to take the first value, the a, and we're going to drop it. And then we're going to say 3 times negative 3 is negative 9. Add the next coefficient, the 5, to the negative 9. 5 and negative 9 is negative 4. Now we're going to take 3 and multiply it by negative 4. So everything that ends up below this line on the chart, we multiply by that value that we're evaluating. So 3 times negative 4 is a negative 12. And 4 minus 12 is negative 8. 3 times negative 8 is negative 24. And 12 minus 24 is negative 12. And 3 times a negative 12 is a negative 36. And 21 minus 36 is a negative 15. So if we did this correctly, 3 is not a 0 of our function. What we're saying is that f of 3, if I plugged it into the function, is negative 15. So let's test it. Here it is, entered into the function, the value of 3. Go all the way to the front of it. So negative 3 times 3 to the 4th, plus 5 times 3 cubed, plus 4 times 3 squared, plus 12 times 3, plus 21, let's hit enter, is equal to negative 15. So we did our synthetic division correctly, and we did find the value, f of 3 equals negative 15. It's not a 0, but perhaps this is an easy way to evaluate polynomial functions. Let's take a look at example 4. We're going to use synthetic division to find f of 1 and q of x, and that's really the power of synthetic division, is finding that simpler polynomial that we can work with. And we're going to check, as we do this, if x minus 1 is a factor of our starting polynomial. So let's set this guy up. We're going to take 1. We're dividing by x minus 1. So once again, that's the factor. So x minus 1 equals 0, x equals 1. And in our synthetic division, set up our chart. Let's make sure our polynomial is in descending order. It is. So let's take these coefficients as they occur and write them across the top of the chart. And then drop the first one below the line on the chart. Start multiplying and adding. 1 times 3 is 3. Negative 2 plus 3 is 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. Negative 8 plus 2 is negative 6. 1 times negative 6 is negative 6. 5 minus 6 is a negative 1. 1 times negative 1 is negative 1. 1 minus 1 is 0. Yay! We just found out that f of 1 equals 0. So x equals 1 is a 0 of the function. Now let's talk about that q of x. What we've just done is we've reduced our polynomial by 1 power. These are the coefficients of those powers. So since we started with the x to the 5th, q of x is now going to be 3x to the 4th. See, we reduce it by 1 power, plus 1x to the third plus 2x squared minus 6x minus 1.